All right, guys, what we're going to be doing here is taking our factoring skills and using our rational functions and rational expressions to another level, and we'll be taking two or more of those rational expressions and multiplying them together. All right, so we're going to be simplifying rational expressions that involve more than one fraction being multiplied or divided, and we're going to be able to represent division as multiplication by a reciprocal, which is something that we need to discuss. And it's probably not a new idea because it's something that should be covered in Algebra 1, but just in case, we're going to make sure that we talk about it a little bit today. All right, so we're going to start off with this first expression, which says that 3 over 8 is going to be multiplied by 20 over 6. And what we're going to begin doing here is, just like we would do if these were polynomials, we are going to factor. All right, so we have to make sure that we're continuing to factor these expressions. All right, so factor that thing. That thing can be factored if you look at each of its components as numbers that can be broken down, right? So 3 cannot be factored, all right? So nothing you can do about that 3. 3 is a prime number, so there's no way that you can divide it into smaller parts. But 8, you could break down. 8 is actually 2 times 2 times 2. So if I take 8 and I make a little tree, I could rewrite 8 as 2 times 4. And then 2 can't be broken down any further, but 4 can. So I could rewrite 8 as 2 to the third power. All right, let's do the same thing with 20 and 6. If I break down the number 20, I'll get, let's just say 2 times 10. 2 can't be broken down anymore, but 10 can, and 2 times 5. So I'm going to end up with 2 squared times 5. So what I'm doing is completely factoring these numbers. And 6 is 2 times 3. Those numbers can't be broken down any further. So I'm just going to write it as 2 times 3. All right, so I've taken that original expression and stripped it down so that now it's just a product of a bunch of factors that do make up the numbers we started with. So now I'm just going to rewrite this all as one component, because I know that if I multiply two fractions, I can just multiply my numerators and multiply my denominator. So I'm going to write it out as 2 times 2 times 3 times 5. And my denominator is going to be 2 times 2 times 2 and another 2 times 3. And the reason I do all this is because I want to see if there's any way for me to cancel anything. Are there any 1s in here? Well, 2 divided by 2 is 1, so I can cancel those. And another 2 divided by 2. I don't have any more 2's in the numerator, but I do have a pair of 3's that I could cancel. And at this point, I'm done canceling, so what am I left with? Well, I still have a 5 in the numerator, and I have 2 2's in the denominator, so that ends up being 5/4. So this original expression actually just equaled 5/4. And in order to get there, we had to factor, and then we had to simplify, and then we had to kind of put it back together in the end, all right? So just like we did in our previous lesson, we're breaking it down and then canceling if we can, and then putting it back together. This is no different, all right? Let's apply this now to an expression that involves some variables, okay? So let's take a look at B. B says that 3x to the 4th divided by 4, and I do want you to view these as two components, right? This is our numerator, and it's being divided by this denominator, and this looks rough. So what we need is a rule for dealing with situations like this that you probably learned when you were in Algebra 1. And so the rule is when you're dividing by fractions. So I'm just going to use a general example here, and I'm going to say that I have two fractions. One is a over b, and the other is c over d. All right, I'm dividing these two fractions, and I'm going to do kind of what I just did. I'm going to highlight my numerator. All right, just lightly there, and I'll highlight the denominator here and just show that those are two separate fractions. So if I'm dividing these two fractions, what I would rather do is multiply the numerator by the reciprocal of the denominator. All right, so, and just to show you where those are, right, our numerator is this thing that I highlighted in this light yellowish color, and the denominator is the green one. Okay, so I'm going to multiply by the reciprocal of the denominator, and what that's going to end up looking like is it's just going to be a over b. This first fraction doesn't change, but instead of dividing, I'm going to multiply, And instead of dividing by c over d, I'm multiplying by d over c because I'm using the reciprocal. So I'm flipping that bottom fraction. And this is just going to look like AD over BC. So it would be hard for you to notice that these two things are the same without knowing this reciprocal rule. And this is the rule that we're going to apply to problem B. So we're going to say that instead of doing this division here, what I would rather do is I would rather rewrite this as 3x to the fourth over 4. That's my first fraction. But instead of dividing, I'm going to multiply. And I'm going to multiply by 10 over 9x because that's the reciprocal of that denominator. And now I'm just going to treat this exactly the same way that I treated the last one. I'm going to set this up as just one fraction because when I'm multiplying these two fractions, I'm just multiplying the numerator and the denominator, and I'm going to factor everything. So I have 3x to the fourth times 10 is really just 2 times 5 if I break it down. 4 is really just 2 squared, and 9 is really just 3 squared. And so now I can kind of look at what's going to cancel here. And so I see that I have a 2 in the numerator and I have 2 2's in the denominator. So I'm going to just be left with the 1 2 in the denominator. I have a 3 in the numerator. I have 2 3's in the denominator. So I'll be left with 1 in the denominator. I can't do anything about that 5, but I do have 1x in the denominator, so I can take 1 from the numerator. And so what I'm left with then is 5 times x to the third over 2 times 3, or 5x to the third over 6. And so that's as simplified as we can get here. And we're just going to do one more, and then I'm going to leave the last one for you guys before you get to class. All right. So luckily we're not dividing here, so we're not going to have to do any reciprocal business. But we can factor everything, which is what we should always do first anyway. So I'm going to factor all of my polynomials that can be factored. My numerator of this first fraction can be factored using difference of squares. So I'm going to rewrite this as x plus 3 times x minus 3. My denominator would be the AM method. If I make a quick list of the factors of -8, I'm going to go with -4 and 2 because those add up to -2. So x minus 4 and x plus 2, and times x minus 4 over x minus 3. So remember, when I multiply these together, my numerator is going to all come together, my denominator is all going to come together, so at this point I can cancel if there is anything that cancels. So I see an x minus 3 in my numerator and denominator, those equal 1. I see an x minus 4 in the numerator and denominator, that also equals 1, and I'm just left with x plus 3 over x plus 2. And that's as simplified as that one gets. So before you come in tomorrow, I'd like you to do D, see if you can fully simplify that one, and then we'll practice when we get to class.